Hello students, welcome to the classes. So in this session we will see some of the important integrals. So we'll derive some 6 formulae based on the substitution method. Okay, so let's say integrals of special forms. Integrals of special forms. Okay, so in that, let us first see the first derivation, integration of 1 by x square minus a square dx. So integration of 1 by x square minus a square dx. So this integral is equals to 1 by 2a log of mod of x minus a by x plus a plus constant of integration c. This integral equals to 1 by 2a log of mod of x minus a by x plus a plus c. So we should derive this problem or derive this formula. Okay, so what to do? Let's take this integral as I. Let I equals to integration 1 by x square minus a square dx. Right. So now I will use the formula a square minus b square. What is a square minus b square? A minus b into a plus b. Right. So I will use that formula here. So what is your I will become? Integration 1 by x square minus a square will become x minus a into x plus a, and integrating with respect to x. Right, I am writing x square minus a square as x minus a into x plus a. So now I should modify the integral, and I should modify the numerator of the integral, so such that I get these two terms above. I should get x minus a and x plus a above. I should modify the numerator like that. That is because later on we can split it into two integrals. So to modify like that, what I will do, I told I should get these two terms, right? So I'll write what? X plus a and x minus a. Okay, so what I will do is, here you see, if I write minus sign, now what happens? X minus x cancel, minus into minus, plus a plus a, you get 2a, right? So a plus a, you got 2a. So the numerator you are getting 2a here, but here numerator is 1. So to cancel that, I will divide by 2a outside. 2a is a constant. You can multiply and divide by outside. It doesn't make any difference. But you can't multiply a variable inside and divide by a variable outside. But right, because it's a variable. So for a constant, you can multiply constant inside, divide it by outside, the same constant. But you can't do it for the same, for the variable. Right, so here a is a constant, 2a is a constant. So here we are getting numerator as 2a. We are getting numerator as 2a. Why? X minus x cancel, minus into minus plus, a plus a is 2a. 2a and 2a cancel. Right, we get 1. Right, so that's why I am dividing by outside 2a. So here I write x minus a into x plus a dx. That is how I am modifying what? The integral. Now what's the next step? See, now I will split the integral. 1 by 2a as it is. Now I will split into two integrals. One is integration of x plus a divided by x minus a into x plus a dx. I am splitting this integral x plus a divided by this minus integration. Now x minus a divided by this, right? X minus a divided by x minus a into x plus a dx. Okay, so I am splitting the integrals into two different integrals. Now you see x minus a x, just a second. Now you see x plus a and x plus a cancel. Now here x minus a and x minus a cancel. So here what you are left with? We are left with 1 by x minus a. Here we are left with 1 by x plus a. Right, so see here, I will write this I equals to 1 by 2a integration of 1 by x minus a dx minus integration 1 by x plus a dx. Right, I am splitting this integral and I am simplifying it. Then I got these two integrals. So let's do one thing. Let's evaluate these two integrals separately. Let me call this as what? I1. Let me call this as I2. Okay. So I equals to 1 by 2a outside as it is. 1 by 2a as it is. This is I1 minus this is I2. I am calling it as. Right. I1 minus I2. I call it as equation 1. Right, where I1 is what? I1 is integration 1 by x minus a dx. Right, and I2 is what? Integration 1 by x plus a dx. Right, so now use substitution method to find this I1 and I2 separately. Okay, so what I will do here is, here I will substitute, put x minus a equals to t. Right, I am using substitution method. I am substituting x minus a equals to t in the integral I1. Okay, so differentiate with respect to x. Differentiate with respect to x. Differentiation of x 1. A is a constant, its differentiation is 0. Equals to t differentiation dt by dx. Now dx into 1 dx equals to dt. So we got dx equals to dt. Now I1 equals to integration 1 by x minus a is nothing but t and dx is nothing but dt. Now what is integration of 1 by t? Log of mod of t. So I write log of mod of t. Right, now I1 equals to log of mod of, what is t? T is nothing but x minus a. I will substitute the value back. Right, t is nothing but x minus a. So I call it as equation 2. This is equation 1. I evaluated I1. I call it as equation 2. Now evaluate I2. Now here put x plus a equals to something called as u. Okay, so some variable. Here I have taken t, there I am taking u, some different variable. Okay, now differentiate with respect to x. Differentiate with respect to x. Differentiation of x is 1. A is a constant, its differentiation is 0. Equals to u differentiation du by dx. Now dx into 1, dx equals to du. Dx equals to du. Now I2 equals to integration 1 by x plus a is nothing but u and dx is nothing but du. What is integration of 1 by u? Log of mod of u. Right? Log of mod of u. Now I2 equals to log of mod of, what is u? U is nothing but x plus a. U is nothing but x plus a. I call it as equation 3. See, we got the value of I1, we got the value of I2. Substitute value of I1 and I2 in the given equation, equation 1. So I will write, put equation 2 and equation 3 in equation 1. Right, so what do you get? I1, I equals to 1 by 2a. Right, I1, right, I1 is nothing but log of mod of x minus a. Log of mod of x minus a minus I2 is nothing but what? Log of mod of x plus a. Log of mod of x plus a. Right, I'll just do one thing. I'll write plus constant of integration c also here. Right, so I'll write plus constant of integration c. Right, so I substituted the value of I1, I substituted the value of I2. Now log m minus log n. Log m minus log n is nothing but log m by n. I have given the formula 1 by 2a log of m by n x minus a by x plus a plus constant of integration c. Which formula we are using? Log m minus log n. Log m minus log n is nothing but what? Log m by n. Right? So we have given the formula. Just a second. Log of mod of x plus a. Okay, we have given the formula. Right, I'll just write that formula. Whatever the formula I am using here, the formula is given by what? Log m minus log n is nothing but log m by n. I am using that formula. Instead of m we have x minus a. Instead of n we have x plus a. Right? So that's the proof of what? This integral. Now let's see few problems based on this derivation. Let's see the first problem. Integration of 1 by x square minus 16 dx. So let's solve this problem. Let's take this integral as I. Let I equals to integration of 1 by x square minus 16 dx. Okay. So I equals to integration 1 by x square minus 16. We can write as what? 4 square. 16 we can write as 4 square. Now if you compare the formula here, a is nothing but here 4, because a square is 4 square. It means a is nothing but what? 4. Right. So now apply the formula. Okay. If you apply the formula, I equals to 1 by 2a. 1 by 2 into a is nothing but 4. 1 by 2a log of mod of x minus a. A is nothing but 4 divided by x plus a. A is nothing but 4 plus constant of integration c. Right. Now I equals to 1 by 2 4s are 8. Right. Now log of mod of x minus 4 divided by x plus 4 plus constant of integration c. That's the solution for the first problem. Right. So the problems may be as simple as this or maybe a little complicated. Right. So let's see one more type of problem which needs some modifications. Right. Let's take the second one. Okay. Integration of 1 by x square minus 6x minus 7 dx. Let's say we want to solve this problem. Okay. So let's take this integral as I. Let I equals to integration 1 by x square minus 6x minus 7 dx. Okay. So now we have to solve this problem using completing square method. So what is completing square method? You all learned in 10th standard. So let's see what is completing square method here. For that we need two formulae. One is a plus b whole square, which is given by a square plus 2ab plus b square. One is a minus b whole square, that is nothing but a square minus 2ab plus b square. Now here we need to use one of them. So which one to use here? You should check for the sign of x, sign of coefficient of x. X coefficient here is minus 6. If x coefficient is minus or negative, then you should use a minus b whole square. If this coefficient is positive, then you should use a plus b whole square. So in this problem, I should use a minus b whole square. Right. So see here how I will simplify this. Okay. So I will rewrite it. I will modify it. See here. X square I will keep it as it is minus. See, x square is similar to a square. It means a is nothing but what here? X minus. I need to modify this 6x in the form of 2ab. For that what I will do is, I will write 2 as it is. A is nothing but x I told. So 2a, I should write b here. So I should write b such that if you multiply all these three terms, you should get 6x back. Now 2 into x, 2x, we have 2x into what is 6x? 2x into 3. 2 3s are 6. Right? So here I will write 3 now. So now you see we got a square, we got minus 2ab plus b square. B is nothing but 3. We need plus 3 square. Do we have 3 square here? No. So add and subtract 3 square. Plus 3 square minus 3 square. I am adding and subtracting 3 square, which doesn't make any difference. Now this minus 7, I keep it as it is. That is how I modify. Now see here, all these three terms together, a square minus 2ab plus b square, that is nothing but a minus b whole square. I write it x minus 3 whole square, a minus b whole square. 3 square, 9, minus 9 minus 7, minus 16. I write minus 16 dx as it is. Right, now I equals to integration 1 by x minus 3 whole square minus 16 is nothing but 4 square, and I write dx as it is. Okay, so now what to do? You should substitute x minus 3 as t. See here, put x minus 3 equals to t. Right, now differentiate with respect to x. Differentiate with respect to x. Differentiation of x 1, 3 is a constant, its differentiation 0, equals to t differentiation dt by dx. Now dx into 1, dx equals to dt. Right, we got dx equals to dt. Right, now I equals to, see here, I equals to 1 by x minus 3 whole square. X minus 3 is nothing but t. So integration 1 by t square plus t square minus 4 square dt. Why? See here, x minus 3 is nothing but t here, minus 4 square as it is, and here we have dx. Dx is nothing but dt. I am writing dt. Now you compare here. You compare this formula and this one now. Instead of x, here we have t. Instead of a, we have 4. Instead of dx, we have dt. So if you apply that formula, what do you get? 1 by 2a. A is nothing but here 4. Log of mod of x minus a. Here instead of x I write t. T minus 4 divided by t plus 4 plus constant of integration c. Right, I am just applying that formula. Instead of x I am writing it as what? T now. Okay, so now I equals to 1 by 2 4s are 8. Now log of mod of, what's the value of t? T is nothing but x minus 3. Substitute the value of t back into the equation. T is nothing but x minus 3 minus 4 as it is. T is nothing but x minus 3 plus 4 as it is, plus constant of integration c. Right, now I equals to 1 by 8 log of mod of x minus 3 minus 4 minus 7 divided by minus 3 plus 4 plus 1 plus constant of integration c. That's the solution for the second problem. Now let's see the second derivation. The second one, integration of 1 by a square minus x square dx is nothing but 1 by 2a log of mod of a plus x divided by a minus x, now plus constant of integration c. We need to prove this formula. Okay, so let's do one thing. Let's consider this integral as I. Let I equals to integration of 1 by a square minus x square dx. Now we know the formula, a square minus b square. is nothing but a minus b into a plus b. Right. Now see here, I equals to integration 1 by a square minus x square, we can write as a minus x into a plus x, and I write dx. Right. Now as in the previous case, we need to modify the numerator. Okay. See what I will do. I will write a plus x term. Also I will write a minus x term divided by a minus x into a plus x dx. Now here I should write either plus sign or minus sign. So if you write plus or minus, whatever sign you write, x terms should get cancelled. We should be left with only the constant terms, so that I can divide by constant outside and make it to equal to 1. For that, see, already we have plus x minus x. To cancel them, I should write here plus x plus into minus minus x. Plus x minus x cancel. A plus a, 2a, but numerator is 1 here. So to cancel that 2a, I will divide by 2a outside. It's exactly similar to the previous derivation. Right. So now I will split and write 1 by 2a. Okay. Integration of a plus x divided by a minus x into a plus x dx, plus integration of a minus x divided by a minus x into a plus x dx. Okay, so I am splitting it. First I take a plus x and denominator, then I take a minus x and denominator. Now here you see a plus x cancel, and here a minus x cancel. What do you get now? I equals to 1 by 2a, and here integration 1 by a minus x dx plus integration 1 by a plus x dx. Right. So now what I will do, I will consider this as I1 and I will consider this as I2. So now I equals to 1 by 2a integration I1 plus I2. Okay, so I will call this as equation 1. What is I1 here? I1 is nothing but integration 1 by a minus x. I will write it here, where I1 equals to integration 1 by a minus x dx, and I2 equals to integration 1 by a plus x dx. Right. Now how do you solve I1 and I2? Use substitution method. Now for I1, put a minus x equals to t. Right. Differentiate with respect to x. Differentiate with respect to x. Differentiate with respect to x. A differentiation 0 because it's a constant, minus x differentiation is 1. T differentiation dt by dx. Dx into 1 dx, and equals to, I write minus that side, minus dt, or it's like multiplying by minus sign on both sides. So we get dx equals to minus dt. Right. Now what is I1? I1 is integration 1 divided by a minus x, that is nothing but t. Dx is nothing but minus dt. Right. Now I'll take minus outside. I1 equals to minus integration 1 by t dt. I am taking minus outside. Integration of 1 by t. Integration of 1 by t, log of mod of t. Right. Now I1 equals to minus log of mod of t is nothing but what? A minus x. A minus x. I call it as equation 2. Right. Now what is I2? Yes. Here to solve I2, substitute, put a plus x equals to some other variable u. I will substitute a plus x as what? u. Now differentiate with respect to x. Differentiate with respect to x. A is a constant, its differentiation 0. X differentiation is 1. U differentiation is du by dx. Now dx into 1 is dx equals to du. Right? Now I2 equals to integration 1 by a plus x is nothing but u. Dx is nothing but du. Right? Integration of 1 by u. Log of mod of u. Right? Now I2 equals to log of mod of, what is the value of u? U is nothing but a plus x. So u is nothing but a plus x. I call it as equation 3. Now substitute the value of I1 and I2 in the given equation 1. So I equals to, you write equation 2 comma 3 in equation 1. Right, I equals to 1 by 2a. I1 is nothing but what? Here I'll write minus log of mod of a minus x. That is nothing but I1 plus I2. Plus I2 is nothing but what? Log of mod of a plus x. I write plus constant of integration c. Here I'll write plus c also, constant of integration. Now here you can see log m minus log n. What is log m minus log n? See, we have seen this formula. Log m minus log n is nothing but log m by n. Right? So log m minus log n. So if I apply that formula, we get 1 by 2a log of m here is nothing but a plus x divided by n is nothing but a minus x plus constant of integration. See, that's the proof of this formula. Now let's see few problems based on this formula. Let's see the first problem. Integration of 1 by 16 minus x square dx. Okay, so let's take this integral as I. Integration 1 by 16 minus x square dx. Now I equals to integration 1 by, how can you write 16? 16 we can write as 4 square minus x square dx. I am writing 16 as what? 4 square. Now is it not in this form? A square minus x square. If you compare, the value of a is nothing but what? 4. So use the formula directly here and substitute the value of a as what? 4. 1 by 2a. 1 by 2 into a is 4. Log of mod of a plus x. A is 4. So 4 plus x divided by 4 minus x plus constant of integration c. Now I equals to 1 by 2 4s are 8. Right, and log of mod of 4 plus x by 4 minus x plus constant of integration c. That's the solution for this problem. Right, so this is a simple problem based on this formula. Okay, so let's see one more problem which is based on the same formula but which involves what? It involves the completing square method. Okay, so let me erase this. Let me erase this. Yes. So let's consider one more problem. Let's consider the second problem. Integration of 1 by 7 minus 6x minus x square dx. 7 minus 6x minus x square dx. Okay, so now let's solve this. Let me take this as I. Let I equals to integration 1 by 7 minus 6x minus x square dx. Okay, see here how I will solve. I need to express this in this form. For that, what I will do, first, as we have minus sign for x square, what I will do is I will take the minus common from these two terms. I am taking minus common from these two terms. What we get? If I take 7 as it is, I am taking minus common. Minus x square will become plus x square. Minus 6x will become plus 6x and dx. Okay, so now I equals to integration 1 by 7 minus, now how do you express this? This you have to express in the form of what? A plus b whole square, because I told for coefficient of x you should check whether you have plus sign or minus sign. Coefficient of x is positive, so we should use which formula? A plus b whole square. What is a plus b whole square? A square plus 2ab plus b square. Right, now see here, a square is nothing but x square plus next term is 2ab. See here, I will write in that form 2 into a is nothing but x here, because I told a square is nothing but x square. Right, it means a is nothing but x. Now 2, a is x, and I should write b. Right, I should write b term such that if I multiply all these three terms, I should get 6x here. 2 into x, 2x. 2x into what is 6x? 2x into 3 is 6x. Right, so 2 into x into 3. 2 3s are 6x you get. Now, you should add b square and subtract b square, right? What is b value here? 3. Do we have 3 square here? No. But we need 3 square to write in the form a plus b whole square. Right. So what I will do is, I will add 3 square and I will subtract 3 square. I am adding 3 square and subtracting 3 square. Now here you see, I equals to integration 1 by 7 minus a square plus 2ab plus b square. All these three terms together, I write it as what? X plus 3 whole square. A plus b whole square minus 3 square is how much? 9. And I write what? Dx. Right. Now what's the next step? Take this minus inside and multiply. So what do you get? I equals to integration 1 divided by 7 minus into no sign means plus here, minus into plus, minus x plus 3 whole square. Right, now next is what? Minus into minus, plus 9 dx we get. Right, now I equals to integration 1 divided by 7 plus 9 16 minus x plus 3 whole square dx. So what's the next step? I equals to integration 1 divided by 16 is nothing but 4 square minus x plus 3 whole square and dx. Right, so what's the next step? Now I will use what? Substitution method. What I will substitute as t? I will substitute x plus 3 as t. See here, put x plus 3 equals to t. Right. Now differentiate with respect to x. Differentiate with respect to x. Differentiate with respect to x. Differentiation of x is 1. 3 is a constant, its differentiation 0. And t differentiation dt by dx. Now this implies, okay, take dx here, dx into 1, dx equals to dt. So we get dx equals to dt. Right, now I equals to integration 1 divided by 4 square minus 4 square as it is minus x plus 3 is nothing but t here. So you get t square and dx is nothing but dt. Now is it not in this form? Right, it is in the form a square minus x square dx. Here 4 square minus t square dt. Now instead of x here you have t, instead of a here you have 4. Apply that formula. 1 by 2a, 1 by 2 into a is what? 4. Log of mod of a plus x we have, instead of a we have 4, instead of x we have t, divided by a minus x, 4 minus t, plus constant of integration c. Right, now I equals to 1 by 2 into 4 is 8, log of mod of 4 plus t, what is t, x plus 3. Right, I will substitute the value of t, x plus 3, divided by 4 minus t is x plus 3, plus constant of integration c. Now here you see 4 plus 3, 7. Next 4 minus into plus minus, 4 minus 3, 1. See here, I will simplify it and I'll write the final answer here. 1 by 2 into 4 is 8 we have done. Log of mod of 4 plus 3, 7 plus x as it is, 4 minus into plus minus, 4 minus 3, 1, and minus x, 1 minus x, plus constant of integration c. That's the solution for this problem.